Welcome to Get Your FRQ On. This question is from 2012. It's question 5, and it is not calculator active. In the question stem, we have a young baby bird, which is weighed early in its life, and at t equals 0, it is 20 grams. We have a function b of t that represents the weight of the bird at some value of t, but we don't really know what b of t is yet. But we do know that dB dt is given by the function 1/5 of 100 minus b, where b is the current weight of the bird. In part A of the question, we are asked whether the bird is gaining weight faster when it weighs 40 grams or when it weighs 70 grams, and to explain. So the rate at which the bird is gaining weight when it weighs 40 grams, even though we don't need to know when that actually happens, we just need to know its current weight is 40 grams, we can get just by using 40 in our dB dt. Remember, dB dt is in terms of b, which is the bird's weight. So dB dt when b of t is 40 is 1/5 of 100 minus 40, which is 1/5 of 60, which is 12 grams per day. dB dt when b of t is 70 is 1/5 of 100 minus 70, or 1/5 of 30, which is 6 grams per day. And at this point, it's just a simple comparison problem. Since 12 is greater than 6, the bird is gaining weight faster when it weighs 40 grams than it is when it weighs 70 grams. In part B, we are asked to find the second derivative of the function b in terms of b, and then asked to determine if the function b can resemble the graph provided in the question stem. Well, we don't have d squared b dt squared, so we're going to have to find it. To do this, we're going to differentiate our dB dt. And keep in mind that since b is itself a function of t and we're differentiating with respect to t, this is an application of the chain rule. So we're going to have 1/5 of 100 minus b times, 1/5 times the derivative of 100 minus b, which is just going to be negative 1 dB dt. All right, so if we move the 1/5 out, we get, or the negative out, we get negative 1/5 dB dt. We already have an expression for dB dt. That's 100 minus b times 1/5. Negative 1/5 times positive 1/5 is negative 1/5, negative 1/25 of 100 minus b. And then we have to do a little bit of analysis here. For t between 0 and 100, d squared b dt squared is less than 0. All right, so the graph of b should be concave down everywhere between 0 and 100. But the graph provided is concave up at least part of this interval. You can tell from looking at it that it's concave up at least over part of that interval, approximately half. So we would conclude that the graph provided could not possibly be the graph of b. In part C, we are told to use separation of variables to find a function y equals b of t, and do so using the initial condition b of 0 equals 20. So we start with our dB dt equals 1/5 of 100 minus b. We want to separate the variables, so at this point we have to divide both sides by 100 minus b and multiply both sides by dt. So we get dB over 100 minus b equals dt over 5. If we integrate both sides, we get another true equation. So now we have the integral of dB over 100 minus b equals the integral of dt over 5. Anti-differentiating both sides, we get the negative natural log of absolute value of 100 minus b equals t to the 5th plus a constant. All right, now since our values of b are between 0 and 100, we don't have to worry about 100 minus b being negative, so we don't need the absolute value symbols here. So we're going to get rid of them. That leaves us with negative natural log of 100 minus b equals t over 5 plus c. If I move the negative over, natural log of 100 minus b equals negative t fifths plus c. Then we have to exponentiate both sides. So b of t is 100 minus e to the c times e to the negative t over 5. Now we have to solve for c using our initial condition. We know that b of 0 should be 100 minus e to the c times e to the negative 0 over 5, and that this should equal 20 because we're given that b of 0 is 20. And if we solve that for c, we're going to get e to the c equals 80, so c is the natural log of 80. So if we substitute this in, and usually when you solve a differential equation in a free response question, you are expected to solve it explicitly for y. You're not supposed to have 3y or y plus 7 or anything like that. So we want b of t equals, and then e to the natural log of 80 is just 80. So we would get b of t equals 100 minus 80 e to the negative t fifths.